Thank you, Jen, for that introduction. Where? Thank you.
Oh,
So thanks for joining us today.
hello.
Here we are. We have a pretty packed agenda, but we're going to start by talking about why we visualize. So we're going to look at the science behind visualization. Why do we visualize in the first place? Why is this even important? Why do we care? And after we talk about that, we'll get into the weeds a little bit. We'll start talking about perception. How do we actually perceive the things that we see? How do we interpret what we see? And then we'll get into part 2, detection. What can we do to influence the way that things are perceived? And then finally, we'll talk about selection. So how do we overall communicate, maybe by chart types, or even in the everyday world, how do we communicate things about ourselves with the choices that we make? And then finally, with any time remaining, we'll open it up for any questions and discussion. So why do we visualize? Why is this important? And it actually has to do with the way that our brain fundamentally works. So we have our cerebral cortex, which is just the outer layer of our brain. And that's what's responsible for things like consciousness, awareness, decision-making, memory. And approximately 50% of our cerebral cortex is devoted exclusively to visual processing. To give you a little bit of context, another sense, hearing, that actually takes up less than 5%. So 50% is a lot. And what this means is that we actually process images 60,000 times faster than we do text. That's why this is so important. As humans, it's in our nature to have this impulse to just find patterns, to detect things that match and make sense, to make sense of chaos. And if you're not sure you believe me, how many of you are familiar with this game up on the screen? Anybody? Raise your hand if you've ever played Candy Crush before. Yeah? I have. I do it on my commute every morning. Why is this so addictive? And it's actually because it's about making patterns, connecting things. And this gives us happiness. It feeds into that impulse that we naturally have. But visualization is more than just images and pictures, charts when we're talking about data. Visualizations actually can also impact the way that we perceive words whenever we can connect visuals to them. So I'm actually going to hand it over to Mico to do a fun exercise with you to show that point.
Okay, how's everybody doing? Good. Okay, so I actually have a fun exercise I want to do with you guys. Could everybody do me a favor? Does everybody have a book or a piece of paper and like a pen or pencil they could take out for a minute? Anything will do. As long as you can scribble on it, you guys, we're going to have a little bit of fun for a minute to really drive this home. All right? I give everybody, again, doesn't have to be fancy. If you can scribble on it and you have a pen or pencil or marker, that'll work. Okay, so the question that I have, we looked at Candy Crush, and for those of you who play Candy Crush, it's obsessive. But one of the things that people tend to not realize is that in order for us to really get knowledge, you gotta have data and context. So I wanted to do a quick word exercise. I have the word fresh on here, and I want you guys to do me a favor and draw a single picture, the first picture that comes to mind, one picture, when you hear the word fresh. So do me a favor on your paper, just draw out the first picture that comes to mind when you hear the word fresh. And for those of you who don't have paper, just hold the picture in your head. And when you're done, just look up, and I'll take that as your acknowledgement that you are done. If you look at me. Okay, awesome. So, how many of you got a picture that maybe looked like this? Okay, I'm just curious, how many of you got something else? There's one person, what'd you get? You got a tool? Oh, a cool guy. Okay, it's fresh, that's fine. Okay, perfect. Now I want to visualize another word, one that we know all too well in data. The word increase. So draw one picture, the first one that comes to mind when you hear the word or see the word increase. Very common word, right? And you could just look at me when you're done. All right, increase. Okay, awesome. How many of you got something that looked like this? Okay, that's what I thought. Obviously, I've done this before. So here's the fun part, right? The reason that I put these two pictures on here is because when you think about wording, right? The reason that you had in the word fresh, you had a picture of a leaf or a fruit is you had something that portrayed color and it had feeling. And to Meyer's point, it essentially appealed to the cortex or the right side of your brain, okay? And when we looked at the word increase, a lot of you associated an arrow. Now, the reason I did this wording exercise is because within corporate, we tend to like to use words like maximize, optimize, increase, and decrease. And the words are very dead, but we expect people to take action on it, right? So I just want to bring this up because right now we're talking about perception is reality. And I think what we just saw is that a lot of times we say something and we say things that people understand, but then we write things somehow in data that they don't. So I thought this would be interesting to bring up. I have one more exercise, which is grow. So I'm going to do it one more time, and I just want to prove a point. So how many of you, do me a favor quickly, can you draw a picture for the word grow? This should be interesting. You could just look up at me when you're done. Okay, so how many of you, once again, got the leaves and the fruits? How many of you got the arrows? So here's what just happened. For those of you who got the leaves and the fruits, you were using the right side of your brain. And for those of you who got stuck in the arrow from the last picture, you were stuck in the left side of your brain. And so now I'm going to hand it back over to Maire, and she's going to explain to you what happened there. All right. Thank you guys for participating, by the way. Thank you.
So, fun exercise, right? Let's talk a little bit about perception. Because perception, as Mico said, perception is reality. My perception of the world, that's what I believe to be true. That is my reality. That is my truth. And so perception is really important because that is how people build up their universe. That's how people make decisions. So let's play another little game. Let's imagine that you wanted to subscribe to a newspaper and you had these three options. Which would you choose? You have a web subscription for $59, you have a print subscription for $99, and a print and web subscription for $99. How many of you would choose the web subscription? Okay, quite a few people. How many of you would choose the print subscription? Nobody. How about the print and web subscription? Okay, a few hands. So interestingly, this maybe shows some change over time in how we consume our news media, but when this experiment was done with students at MIT, 84% chose the print and web subscription. What if we look at this a different way? Nobody chose that second option, that print-only subscription. So what if we remove that from the choices entirely? So imagine that we didn't just do this exercise. When this experiment was done, it was done with a totally different set of students, and they were only given these two options. So in the prior version, 16% chose the web subscription. Imagine you're in the same scenario. How many of you would choose the web subscription? Pretty much everybody. How many of you would choose the print and web subscription? Very few people. Did anyone change their mind? I see a few hands. So when this experiment was done, over 50% chose the web subscription only. Why is that? It's because value is relative. If you went out and bought a new car, and you thought you got a great deal on that car, and then you come home to find out that your next door neighbor bought the same car for a lower price, how would you feel? Suddenly you didn't get such a great deal, did you? So value is relative. This is this anchoring effect is what it's called. And it basically means that we need context in order to assess what something means, how good or bad something actually is. So visualization, that's just what we see. That's this visual stimulus that comes in. But perception, that's how we see it. That's how we interpret it. And that's how we then go and make decisions based on it. So let's talk about an example in real life with data. What does perception have to do with data? And there's really two components to this, because anytime we're talking about data, there's the data itself that we might be using to drive perception, and then there's the way that we actually present that data. So on the morning of November 8th, 2016, Election Day, most of us were wondering who would be the next president of the United States. How many people thought they knew the answer to that question at the time? A lot of people. Was it due to data like this? Kind of jived with what we thought would happen? But what actually happened? Not what we thought. Why is that? And the reason is that there was bias in the data. So as great as the visual was, as easy it was to see and make a judgment based on the polling data that was out there, we were still wrong because the data had bias. And in this case, there was a bias around education. The average education of those who were polled was much higher than the average education of the actual voter population. And this was the first time, actually, in a recent election where the level of education of the voter actually had a major impact on who they selected. So this resulted in a massive bias in the polling that was done. So imagine that the data's fine. How do we visualize it? How do we actually present it? Because if the data's not biased, if we're happy with the data that we have, then it's just about telling that story with the data, showing some sort of visualization in order to communicate our message to the person who's looking at what we've created. So if I wanted to know how fast our voter population is growing, and have you all know that as well, I might put something like this together, where I see the number of eligible voters over time. Doesn't look very exciting, does it? There's a lot of white space. The line is not increasing very quickly. So I might be tempted to make an adjustment and look at it like this. That looks more fun, right? Looks a lot steeper. If you look at that quickly, how fast is our voter population growing? Pretty quickly, right? Take a look again. It's the same thing I just had, but now that y-axis, it doesn't start at 0. And this can be really misleading, and it again comes back to the way that our brains actually work. When we look at something, we make this automatic and immediate judgment or perception of what we see. And it's not until this more deliberate cognition comes in later that we can really start to understand and interpret it. So if we don't look really closely and actually detect that that axis doesn't start at 0, we're going to walk away thinking, wow, our voter population is growing really, really quickly. So what do we do? Because we have one graph that isn't very exciting, doesn't tell a good story, and we have another one that maybe tells a misleading story. Let's think about the question. How fast is our voter population growing? What are we really interested in here? We're interested in the change. The change is what matters. So when we think about that question and the message we want to communicate, why don't we just plot the change? How fast is our voter population actually growing? So by shifting and focusing on that impact, that change, which is really what matters, we're able to communicate a better story. So what are some takeaways from this? There's obviously a lot going on when we think about perception. The first is that it's just so important to understand your data and to really understand the message that you're trying to communicate. Because if you don't understand it, you can't expect other people to be able to understand it either. The second thing is that change is often what really matters, so highlighting that can be so important in communicating your message. And then finally, provide context. whether it's using the right words or using the right visuals, providing that context, giving people an anchor to know whether something is good or bad, it's pivotal in ensuring that people perceive what they should be perceiving.
And I wanted to add a little bit of context here. I'll just take a minute. So when it comes to dealing with perception, one of the things that I think we have to acknowledge as a data practitioners is that our job is to make sure that because we know that perception is reality, essentially we're in control of reality. When you look at it as data practitioners, we have control of reality. So one thing that you need to make sure is that even though you feel a certain way about data, it's what someone else thinks. It actually doesn't matter what you think and how you feel about the data. On top of it, I want to emphasize the only thing that people care about when it comes to data is change. I don't care what anybody tells you. Remember what I said today. The only thing people care about is change. If you spend most of your time focusing on how to highlight change and focusing on the perception that change will give or the impact it'll have, you will get more out of your data. Okay, so when we went through these slides and we were doing this and we were talking about perception being reality, one of the things that we pointed out is that another map that isn't here is that they basically polled people along the coast. And in case you guys don't know, 80% to 90% of people who travel outside the US live along the coast. Did anybody know that fact? And that's where the media kind of sits. Well, if you compare where they actually poll that data to where the the popular vote happened, it's very parallel. Now, I'm not saying it's the cause. I'm not saying it's correlated. But again, here's an area where data lied. But if they really provided context and said, oh, we're just polling the coast, I think a lot of us could have probably tell what was going to happen. So I think here it's just important to remember that perception is reality. And when you have control of data, you actually have control of reality. Go ahead.
So what is Looker doing about this? So I'm just going to give you guys some insight into some features we already have and some we're working on that should help you all make an impactful visualization that shows really what you're trying to show in the data. So one of those ways is by using custom fields. So let's look at an example. Let's say you want to look at the number or how the voter turnout is changing over time by race. The first thing you could look at is just the number of voters. How many voters are in each demographic group in the last 5 or 6 elections? And you get a graph like this where, you can see the trend over time for white people, but there's so many more white people than other demographic groups in the US that it's hard to tell what the trends are for those groups. So we don't really want to look just at the numbers. But say you're in Looker, you're in an Explorer, and that's the only measure you have. You don't have anything else there to change what you're looking at. That's where you can use a custom field. So right when you're looking at the data, you can make a new field that counts up the number of eligible voters, counts up the number of people who actually voted, and divide those to figure out the percentage of eligible voters who actually voted. And you can do this without having to go into the model and change, add new fields. You don't have to be a data analyst. It's simple enough to just do right here while you're trying to ask the question. And so if we do that, what do we end up with? We end up with a chart more like this, where we can see both how each group is changing over time. From a quick glance, it looks like most groups are staying about the same, but it looks like voter turnout has been increasing for Black voters, especially where it matched the same turnout as white voters in 2008 and 2012 when Barack Obama was running. And then we can also see how voter turnout compares within those groups and how a lot of minority groups, the turnout is a lot lower. So you can kind of, whatever you want to do with this data, figure out how you want to change that. Now we can really see what's going on. What's a way in Looker that you can provide context for your data? I'll just show you a simple example. Single values, they're great. They're great for showing, that one really important metric for your dashboard. But a lot of times, a single number is not very helpful. You don't know what it means, and you don't have any context behind it. So here we're looking at the percentage of 18 to 24-year-olds who voted in 2012. About 45%, that seems pretty good. Maybe you're thinking that seems pretty low. A lot of other countries have a lot higher voter turnout. But really to interpret this number, we need to know how often everyone else votes. So by adding a simple comparison here, we can see that 45% is pretty low, 8% lower than the rest of the population. And now we have context, and we have an anchor for what the data is that we're actually looking at. So I'm going to pass it back to Maire.
Thank you. So we've talked a lot about perception. Let's now focus on detection, which really is the way that we maybe influence how people perceive something. So when we're focused on data, how do we create or highlight patterns and make it easier for people to perceive the things that we want them to see? So we'll again play a couple games with you guys. I hope you're ready. Quickly, how many 9s do you see on the screen? Everyone's staring, counting. Won't even give you enough time. How about now? How many 9s do you see on the screen now? Everyone's still counting? How about now? How many 9s do you see on the screen now? A little bit easier, right? So in the first example, everything was pretty uniform. In the second example, we had tons of color. Everything was a bit chaotic. You couldn't tell what I wanted you to find except hearing me ask you to find the 9s. In this example, I wouldn't have even had to say anything. They jump right out. We're using color to really highlight something specific, make it easier for you to see what's going on. Let's look at a different example, something totally different. How much bigger is circle B than circle A? Get a number in your head. Is it 5 times bigger? Is it 10 times bigger? Is it something in between? Does everyone have that number in their head? Okay. How much longer is bar B than bar A? 5 times bigger? 10 times bigger? Get that number in your head. Does everyone have it? Guess what? They are both, in each scenario, object B was 8 times bigger than object A. How many people were closer with the bars than with the circles? Most of you. Yeah, there's a reason for that. And it actually comes to this spectrum. And it's this idea that there's different ways that we can encode data, and some of them make it easier for the person looking at it to perceive the exact differences more easily. So if we look at something like color saturation or area, like we did with that circle example, those are on the least accurate side. It's really hard to tell exact differences between those objects. But when we move up the scale to the more accurate side, we see things like length and position. This is why so many of you were able to have a much more accurate estimate of the difference between those bars than when we looked at the area of those circles. So let's look at this in some data, and we're going to look at color saturation, actually. And we're going to look at a map.
Can I ask a question really quickly?
Of course.
Has any of you guys read Stephen Few? Anybody know about when he assassinated pie charts? Anybody know about that infamous argument online? So I don't have time to stop, but you should go and Google and look up like Few and pie charts. There is an ongoing decade-long feud about why pie charts are the worst thing to measure. So I thought I would add that part. So people are smiling because you've probably seen the debates online. It's pretty epic.
That's why. That spectrum is why. Thank you. So what if we look at this in the data? I have a map up here that shows all of our states, and it measures voter turnout. Which states had the highest voter turnout? That's not too hard to see, is it? Mississippi, it's pretty dark. We can tell that they had pretty high levels of voter turnout. Minneapolis or Minnesota in there. Wisconsin. What if I change the question? How much did voter turnout differ across states? How much different was voter turnout in Mississippi than, say, Louisiana right next door? That's a lot harder to tell, isn't it? And it's because the question is different. So the first question, we're asking for relative differences. And the lower end of that spectrum, really good for relative differences. We can see in general what's largest and what's smallest. But when we change the question and we want something more accurate, we want to know what is the actual difference. This doesn't cut it. This is really hard to see. So this is when we have to think about shifting up that spectrum. How could we use length? How can we use position to make this more easy to detect? Mico, what have you seen with color in your work?
So when dealing with color, how many people here are familiar with rag colors? Anybody know rag? Red, amber, green? They call them rag. So we were talking about this earlier, right? And we talk about the science of data visualization, and we pretty much have a couple of rules, right? All of us are familiar with traffic lights. So when it comes to rag colors, what we tend to do is we tell people, just don't use green. The reason being is that when you put green on a screen, because all of us are accustomed to traffic lights or we're conditioned through our phones to look at red alerts, we automatically see red as being bad or need attention, and we see green as good. Well, what I've seen happen a lot of times is people overuse the color of green on something, and then the thing that's red, that's the most important, which doesn't have enough real estate to begin with within a visual, tends to get overlooked. So we have a few simple rules I'm going to leave you guys with when it comes to color and rag, which is 1, don't use green. 2, use yellow with caution. And 3, red should be the highlight. Now, some of you may be thinking, if you work for companies that we've worked with, like maybe Coca-Cola or Shell, what do you do if your whole logo is red? Anybody have a logo that's red? What do you do, right? What color palette do you use? So one of the things that we do in those scenarios is we find complementary colors, like let's say maybe an orange or a blue, or we use a lot of grayscale colors in order to complement. But the idea is that just remember this, red is the winner. Remember I told you guys earlier, people only care about change. Highlight the change, use red, everything else is noise. That's what we see with color.
So color can be really powerful. It's really intuitive. We have all of these associations with certain colors, but that means you need to be a little bit careful when you use it. So what is Looker doing about this? We have been working on a project for a while now to improve how the color experience in Looker in general. So around how you pick the colors, how we present them, and what the colors actually are. And I'm going to talk a little bit about making color palettes and how we chose those colors. So there's a few different types of color palettes that we're going to start having in Looker. One of them is probably what you usually think of when you think of a color palette, a categorical palette. It has a variety of colors. They're all different enough that you can tell them apart easily. And they're great for labeling different categories of data. So I'm breaking Mico's rule here a little bit, but this is a map of states that have legalized marijuana across the US. And so
green is valid there, obviously.
Yeah, in this case, it kind of works.
Talking about visualizing grow, I mean, it's valid.
So green is states that have legalized it recreationally. Yellow is states that have legalized it medically. And this is a great use for this type of color palette. Another type that we're working on incorporating is what we're calling a sequential palette. So this is great for continuous numeric data that is moving in one direction. So that would be like population in each state, like this map. It's really easy to pick out the most populous state, California, Texas, not far behind. And in this case, color works here because we're not trying to say how much bigger is Oregon than New Mexico, more populous. But it's easy for picking out the really important points. And then a third type of palette we are incorporating is what we're calling a divergent palette, which is really similar to a sequential palette. It's great for continuous numeric data, but in this case, it's good for data that's diverging from a midpoint. Lots of data like that will be things that go positive and negative with 0 in the middle. Here's an example with the makeup of the House of Representatives after the 2016 election by state. So we can see some states are on one end of the spectrum, like Oregon, where all of the representatives from that state are Democratic, whereas lots of other states like Oklahoma or Nebraska are on the other side of the spectrum, where all the representatives are Republican. And so these are different types of palettes we're looking at, and we're also working on making it so these apply to your data automatically in the way you would expect. So in a sequential palette, we'll be able to calculate the min and the max and distribute the colors evenly for Divergent, we'll be able to figure out where the midpoint is. So when you open up that visualization tab, the colors are going to be what you want them to be, and you don't have to fiddle around with them.
So it's autocorrect for colors.
Yes, autocorrect for colors. Don't quote me on that. Okay. And another thing you want to think about when creating a color palette is making sure it's accessible to everyone. And so the most obvious aspect of that is for color blindness. Color blindness affects 1 in 12 men, with about 8%. Not as many women, but still very important. And so let's look at an example. Here's a palette that you might look at and go, oh, this looks pretty good. We've got a variety of colors. We've got some dark colors, some light colors, pretty much everything along that spectrum. But this is what the palette would look like if you have yellow-blue color blindness, which is the least common kind of color blindness. But even for them, or perhaps especially for them, almost 2/3 of these colors look exactly the same. They're totally indistinguishable from each other. So on the right there, that bright magenta purple and that orange, that looks completely different if you are not colorblind, but that looks almost the same colors. If you have red to green color blindness, which is the most common, you have a similar problem. About 2/3 of the colors are totally indistinguishable. 3 of them even look almost exactly the same. This is a great example of where using red and green is not the right thing to do, because those are so coded in our society, but the most common kind of color blindness makes them really hard to tell apart. So this is something we're thinking about when making our color palettes, so that you don't have to think about this every time you're choosing colors, because making sure every set of colors you pick for every visualization is accessible is hard. So we're trying to do that for you.
Awesome.
Thanks, Lindsey. So we've talked about perception, the way that we interpret the things that we see. And we've talked about detection, which is the way that we influence perception on more of a micro scale, maybe individual data points. Let's now talk about selection, which is how we can influence perception on a more macro scale. And again, we'll start with a little interactive exercise. So imagine that you're at home, nice hot cup of cocoa maybe, watching a movie, starting to think about bed. How many of you would put on outfit A in that situation? Nobody. Yeah, I probably wouldn't either. How about B? Yeah, pretty much everybody. Me too. That seems like the right time to wear your pajamas. Now, imagine that you are going out to a fancy restaurant. Maybe you're going on a date. Maybe you're just having a nice dinner. Would you still wear outfit B? Probably not. I don't see anyone raising their hands there. How about option A now? Yeah. So why does this matter? The things that we choose to present ourselves, when we're talking about data, it really works the same way. None of these outfits are wrong, but they have to fit the occasion. They have to fit the right situation. If you show up at a nice, fancy, fine dining restaurant in your bathing suit, they probably won't let you in. And choosing charts, it's the same thing when you're talking about data. So if we take a look at some data, who voted in 2012? Here's one way that we could represent this. And I can see relative proportions for each generation of who out there actually went and voted that year. But when we think back to that detection spectrum, if I want to compare across these, it's a little bit harder, especially when those angles are similar. And it's because angles and area are so far down on that spectrum. So if I wanted to be able to make that comparison, what would I do? Is a donut chart the right way to do that? Probably not. It's going to be a lot easier if I look at it like this. I can select a chart type that actually leverages one of those detection points are much higher on that accuracy spectrum. So now I'm using length in order to drive someone to perceive that comparison and make that judgment as opposed to area or angles. And that makes a huge difference. But there's a lot of charts out there. There's a lot of options. Mico, why is this so hard for people?
So let me ask a question. How many of you guys here build visuals? All right. How many of you, when you build a visualization, you change a chart once? How many people change a chart twice? How many people change the color than the chart? How many people then change the data and the color but keep the chart? Right? It just seems like a conundrum. So let me explain to you guys the science behind why that's happening. When you're building data visualizations, there's 3 elements that you're dealing with. You're dealing with the data itself, you're dealing with the design portion, and you're dealing with the functionality of what you're building. So what ends up happening is the data and functionality sit on the left side of your brain, and the actual visualization part, how it looks and feels, sits on the right. So essentially your brain is having a war. That's what's happening. So at the time when you're trying to pick the visual, you're focused both on, I hope the data looks great and cool, but I think I need to use the right chart, but wait, the colors don't fit. And all this is happening in your brain. So the rule for that, and we were talking about this earlier, is I tell people when it comes to visuals, there's a couple of rules, which is 1, if it looks cool, the chart's super cool, you're gonna see some, don't use it. Okay? Case in point, who's ever used a spider chart, also known as the radar chart? Okay? I don't even want to ask why. I typically recommend that everybody put their, so if you don't even know what I'm talking about, that's my point. Okay? How many of you has ever used the candlestick chart? If you're not, for those with the hands up, keep the hands up. How many of you are stockbrokers? Okay, those are only people that should use candlestick charts. How many of you don't know what a candlestick chart is? People who are using it, look around. That was my point. So when it comes to chart, honestly, my one rule is that if it looks cool, don't use it. Again, going back to perception, going back to detection, most people don't understand what it is. Just keep it very simple. And going back to Stephen Few, he invented the bullet chart and the spark line because he hated pie charts. So that's what I have to say about charts.
Yeah. There's a reason the bar chart hasn't been reinvented in almost 100 years.
Look at Edward Tufte. A bar chart it's a bar. It hasn't been reinvented, neither has a line chart. So until then, let's stick to basics.
So this is how Looker can come in. So it's easy to get a little carried away with your visualizations. Use a spider chart. They look so fun. But Looker's working on being able to detect what chart you should use for your data better and more automatically. Because you don't want to have to look at this flow chart every single time you're making a visualization, because that would be exhausting. So we're trying to incorporate these types of rules. We're focusing on the core visualizations, what you really need to express the data, not some other more niche visualizations. And we're trying to make that easier for everyone. So you don't have to know exactly when to use a line chart, exactly when to use a bar chart, exactly when to use, a pie chart maybe sometimes, because Looker's going to try and do that for you. And this is going to be even nicer when we start adding a few more chart types for different types of data visualization. So one of these that we're adding is small multiples. And these are great for showing different trends in different groups of data. So this is actually the same data we were looking at earlier, the voter turnout over the last few years by race. And the first chart we're looking at, not the best chart in the world. This does a lot better job of showing you the trends for each group. We can clearly see the voter turnout is increasing for Black people. It is staying the same for most other groups. And then we can also compare how those trends look across the groups. So this is really great for showing those types of data. Coming soon to a Looker near you. A visualization we added recently is bubble charts. And bubble charts are great for showing 3 different variables on one chart. But with great power comes great responsibility. So this is one of those charts you gotta be a little careful with. You don't want to be throwing your bubble charts everywhere. But here's an example we can kind of walk through of a great use for a bubble chart. So this shows the average salary by number of people in different industries. And then the size of the bubble is the growth in that industry over the last 4 years. So at first, it's a little hard to grasp your head around what's going on here. Adding context to these types of visualizations is super important. And how would you use something like this? Say you're coming out of college, you don't know what to do with your life, and you're thinking, what industry should I go into? You can look at a chart like this and go, oh, it looks like mining. I can make a lot of money in mining. and it's growing. I love that, lots of opportunity. But there's not as many people working in mining, so maybe there isn't quite as much opportunity there. Whereas professional and technical services, I know some of us in here will be familiar with that, a growing industry, high salaries, a good number of people working in it, so there might be opportunity there. So I'm sure most of you did a decision like this when you came out of college and went into professional services. Mining versus professional services, a tough choice. So now you can have bubble charts in Looker as well. And sometimes you really do need a specific visualization for a very specific type of data. And so Looker has a framework where you can create completely custom visualizations that really fit your use case. And we are recently rolling that out to all Lookers, so anyone can start adding custom visualizations. And we have some that are already built that you can load into your Looker, or you could build something totally new, totally your own for your specific use case. And so Looker is working on lots of different ways to make visualizations easier for most users, so you don't have to think about some of those hard choices every time you make a chart. But we're also trying to make it useful for more advanced users or more specific use cases. And quick poll, who knows what type of chart this is? Not very many of you, a few out there. That's kind of what Looker is for. This is a sand key chart if you're curious, but hopefully using Looker, you won't have to know that this is called a sand key chart, and we'll be able to help you use it when you should be using it. So yeah.
All right, can I add one more thing before we go?
Yeah.
So the last thing I want to add is we kind of went through this science of data viz, and I think there's some key points that people need to remember. So one is perception is reality. So again, it doesn't matter what you think. It doesn't matter what you feel. Maya Angelou had a good saying, right? When she keynoted when I graduated, she said, people won't remember how you look. They won't remember what you say, but they surely remember how you make them feel. Data is the exact same way. So whether or not you realize it, while numbers don't have emotions, people do. And with perception, that's the emotion. The second part, which was the detection part, I think the important part there is that you have the ability to control reality. So just remember that first you have what people perceive, and then you have the ability to control that. And I think the last part with selection, that's making sure they actually understood what you were perceiving. So we took this take going across the spectrum on the science of visualization to more focus on the brain element of it, because I think when people get into choosing charts, they get so caught up and excited about their data, they forget that they're actually in control and they have the ability to influence people. So that was the point of our presentation.